Hi, this is Sanat. So, welcome to our classes, Graviton classes. Our topic of discussion today is atoms and molecules, and this class is based on secondary level students up to 9th and 10th level. And our topic of discussion is atoms and molecules. Atoms and molecules. Now, before we come across this topic, let us assume a constraint in our daily life. Supposing everything we do in our life, we come across this topic called atom. This term atom. Before going into any topic, the most important thing about any kind of topic is why we need to read such topics. Why atoms? Why not any other thing? Why we called it as atom? Now, atom is a fundamental particle. Someone defined it, atom, as a fundamental particle. Of what? Of everything. Atom is fundamental particle of everything that we come across. Now, the history behind this topic goes back to 400 BC when Demetrius, a Greek philosophers, usually any scientific innovations were made during the time of those only Greek philosophers, scholars. So Demetrius was the first who used the term atomos. It is a Greek term which means uncuttable. From this term we obtain so-called atom. So whenever atom comes to our mind, two cultures must come to our mind itself. That one is Greek culture and the other is our own Indian culture, which defined it as अणु. अणु यानी कि एक जैसे बोल सकते हैं आप लोग सबसे क्षुद्र पार्टिकल जो होता है, कणिका, क्षुद्र कणिका जिसे बोल सकते हैं हम लोग. तो एटम्स इज अ अनकटेबल और इनडिविजिबल फंडामेंटल पार्टिकल. Not only as a particle, it is a fundamental block of chemistry. But his idea of having an uncuttable term was later on rejected. The point of rejection was that lack of evidence. So once Henry Rager, a scientist, once defined that whenever we do not have any evidence and we take it as assertion, then we don't need any kind of evidence to dismiss such assertion. That is, whenever we have no kind of evidence, then we take some certain kind of things into existence or appreciation or assertion. Similarly, we can make certain thing means to disseminate without having any evidence. So Demetrius was the first to know more about atom. It was around 400 BC. Then came around 1808 AD. It was Sir John Dalton. It was he who later on defined atom as the fundamental particle. It is the fundamental particle of matter. It was Sir John Dalton who defined atom as the fundamental particle of matter. And what does the term fundamental means? Suppose, consider a case. Suppose you are preparing a cake. Now certain ingredients are essential, such as the flour, water, butter, the chocos you are inserting over here, the raisins, and so on. Now you can prepare a cake only with the help of certain fundamental things. Now these fundamental things are nothing but, in science it is the atom. When we compare it with the, like you can compare it with the cell, when cell is the fundamental unit of life, it is the fundamental unit, it is also the fundamental unit. Cell is the fundamental unit of a body, of an individual, of an organisms, while atom is fundamental unit of everything around us. It may be living, it may not be living. There, then it was later on various scientists have later discussed about atom, and around 20 to 30 years, around 20 to 30 years of having such, it was later on developed by many scientists like Sir J. Thomson. It was Erwin Schrödinger. It was Summerfield, Bohr's, Neil Bohr, and importantly Ernst Rutherford. Until the time these eminent scientists have made research over this topic, it was simply made that it is the fundamental particle of any matter, and it is the since it is the fundamental, it must not be divisible, that is, it is indivisible, it is indivisible. It was taken into granted as because Sir John Dalton has described such thing. So since it is indivisible, now the terms comes, then what happened when such scientists made researches on this matter? What happened when such scientists discussed about atom? Now on research it was found that atom is not the fundamental quantity, rather it do have certain subatomic. Later on it was discovered that atom has certain kind of subatomic particles. These subatomic particles, when later on discussed, it was around 35 kind of such subatomic particles, 35, of which were most prominent to three of them. One is electron, proton, and neutron, and hence we call them as the fundamental particles. Now these fundamental particles are further discussed later on, and we obtained many other nuclear particles. These are nuclear particles, so we could, when in higher classes we will get into these nuclear particles. Now our topic of discussion must lie with atom and its features. Now once a great scientist, Michael Faraday, once said, I am just jealous of the term atom. Because it seems to be simple to talk about atom, but it becomes too complex. When they are compounded, are discussed or taken into consideration. This means when simple atom, we just can talk about atom, but when its compound form are discussed, then it is quite hard to talk about such kind of things. So now the topic goes on like this. We will go across atoms and then the various models associated with this. Many eminent scientists have discussed about the models of atom. The first one was given by Sir John Dalton, which was called as the Dalton atomic theory. Then came the Thomson atomic model, or plum pudding model, or raisin model, we call it. Then the Rutherford scattering experiment, which was quite appreciated which help us to know more about the nucleus. The second topic of our consideration must be of nucleus. When we get into atom, the primary thing we know about is the nucleus, which will help us to know more about proton and neutron, the other two fundamental particles. After Rutherford, then came Niels Bohr, who discussed the path of the electron. Niels Bohr discussed the path of the electron, how it is circular in nature. Then his kind of limitations were later on oversized by Sommerfeld and Schrödinger through their Schrödinger equations and Sommerfeld's elliptical equations. So our topic now goes on to Dalton's atomic model. Dalton's atomic model. Now, since Dalton by profession he was a teacher, so his assumptions over those days were taken into much granted. His first assumption was that every matter around us is made up of indivisible particles called as atom. यहाँ पे बता दूं कि ये उन्होंने बताया था कि जितने सारे हमारे विश्व में जितने सारे वस्तुएं हैं वो सब एक छोटे से पार्टिकल से बना है जिसका नाम है एटम या फिर अणु. Then it comes to the second point is that the most important feature of this point of this theory and the first postulates, we call it as postulates because it doesn't provide us any practical proof. It was just a kind of assumption. Indivisible. This term is most. This was the only term which separates Dalton's atomic model with the modern atomic model. This is the only term which separate Dalton's atomic model with the other atomic models or the modern atomic models, because this term doesn't involve the subatomic particles. This term doesn't involve the subatomic particles. Now it comes to then the second term is each atoms of same kind of element are identical to one another. Now here if we get into this point, every atoms of same kind of elements are identical. This says that suppose one moves to Australia to pick up sodium and one moves to say Mirzapur to get sodium. Though their objective is sodium, so both of them when gonna move to either Australia or Mirzapur, they both of them have to get sodium. Now it says that same kind of elements have atoms identical, that both the elements, since both the elements are equal, so the atom must be identical with one another. Whereas the third postulate states atoms of different elements are not identical to one another. Taking consideration in the same topic, different elements. Suppose say someone moves to North Korea let it be within India itself, someone moves his from his neighborhood, he pick up sodium, and from other end he purchase suppose potassium. Now both are different elements. Both are different elements. Both shows different properties. Both shows different properties. So they cannot have the same kind of atom. Sodium atom is different from that of potassium atom. His fourth postulate was, in a chemical reaction, the number of atoms associated varies. Keeping these laws of conservation of mass, keeping the law of conservation of mass, that is mass remaining constant on the either of the side, that is the product end and the at the reactant end, their number may varies considering this statement, conservation of mass, that is mass can neither be created nor be destroyed. So this was all about Dalton's atomic model. Dalton's atomic model had certain kind of limitations which were later known when Faraday, Crookes, J.D. Thomson, when they discussed that topic, they made research on such topic, then their kind of limitations was obtained. But till then, Dalton's atomic model was taken into granted, because his theory was only such kind of theory having the strong base, over the field. So his was taken into much granted. Then we comes to Thomson atomic model, or Thomson model of atom. Thomson's atomic model given by J.J. Thomson. Now, before coming into this topic, you must be aware that it was the Thomson who discovered electron. This experiment led to the discovery of electron. But the experiment was performed was Millikan's oil drop experiment. However, this is not under your considerations or your syllabus, so you will get it on higher studies. Millikan's oil drop experiment, where the charge by mass ratio was obtained, and hence the mass of electron was also obtained. So atomic model of Thomson gave us the idea of what an electron is. Now, what does the theory states, or what does the model states? The model states that atom is nothing but a positively charged sphere. It is a positively charged sphere. Where the electrons are embedded in such a manner that this sphere as a whole becomes neutral. And I am speaking it once again. According to Thomson, an atom is nothing but a positively charged sphere in which the electrons are embedded as, the topic is as, resin in a cake. रेजिन, यार जिसको किशमिश बोलते हैं, किशमिश इन केक, और सीड्स इन वाटरमेलन. raisin in cake or seeds in watermelon. So it is also called as the plum pudding model or raisin's atomic model. So this Thomson atomic model forms the base, it gives the base chemistry for the study of atom or for the study of electron. But he has certain kind of limitations which further on discussed by Ernest Rutherford. The Thomson atomic model described an atom, it described an atom, it described an electron, but it discovered electron, but it did not give any idea regarding the motion of the electrons, the presence of the other fundamental particles, other subatomic particles like proton and neutrons. So it was later on discarded, but we cannot say it was totally discarded, but certain facts of it been erased for the time with the development of Rutherford atomic model. So when question generally comes, what was Thomson's atomic model about? Means what was the basic idea of Thomson atomic model? How he compared with it the plum pudding model? What was his limitations? What was his what were the advantages? Now we are always talking about disadvantage, but his experiment made a base. It made a base for the further scientists to know about the electrons, the other subatomic particle, the nucleus. So the advantage of this Thomson atomic model, it gives the idea of electron. It gave the idea of electrons. So discovery of electron was because of this person, J.J. Thomson, and Thomson atomic model is all about this. The second term that comes into our mind is what about proton and neutron? Two facts has to be memorized. One is E. Goldstein. E. Goldstein, he discovered the proton. Now, for granted, certain facts have to be known prejudicially, because those facts you're gonna read it on higher classes, but taking into consideration we will come across certain terms like alpha particles. Now we consider proton as the positively charged particles, and hence these are the alpha particles. These are the alpha particles. This symbol represents alpha. It is alpha particles. E. Goldstein discovered proton, and James Chadwick discovered the neutron. James Chadwick discovered the neutron. What is proton? What is neutron? We will come across such topics. Now, as a whole, these protons and neutrons together called as nucleons. Why? We'll come across this topic. This question must be raised. Why? Because they are nucleons. And what about electrons? Why electrons is not involved in nucleons term? Now we'll come across the second atomic model, that is the Rutherford atomic model. The Rutherford atomic model, or it is also called as the alpha particle scattering experiment. Alpha particle scattering experiment. Now, what is about Rutherford atomic model? It was Rutherford and two of his colleagues who together formed this model. What was the importance of such kind of model was that it helped us to know more about the nucleus, the positively charged particles, the protons. It helped us to know about the structure of the atom. It gives more prominent idea to the structure of atom, to the internal structure of atom. More prominently, we can say that it gives more idea about the internal structure of atom. Now, what is Rutherford model of atom? First of all, we need to discuss about the experimental observations. Before coming into experimental observations, I think you must be aware of certain terms like radium. Now, these are the radioactive elements. These are the radioactive. That means they could decay very easily. Radioactive elements. Radioactive elements. They could not be placed in a manual manner. Hence, such kind of particles need certain kind of metals or elements to be covered with. So, hence, Rutherford model of atom involves such applications also. Now, one other term is foil. You must have almost have taken there. You could obtain a wrapper of gold foil wrapper. Such kind of a wrapper was obtained, a gold foil. Zinc sulfide screen. Zinc sulfide screen. Now, what it helps? What is the role of zinc sulfide? Zinc sulfide helps in scintillations. Helps in scintillations. Scintillation का मतलब चमकना. तो ये जिंक सल्फाइड का सरफेस जहाँ पे रहता है वो चमकता रहता है बस. जिंक सल्फाइड. Now, involvement of a sleet. Normally, if you place two kind of cardboard, suppose assume this as one, and you just make a cut mark over here. Then you get tiny surface to penetrate the light. You get a tiny surface to penetrate the light. This forms the slit. Now, we will come across the topic. First is involvement of a radioactive element. At his point of time, he used radium for such purpose. A lead emporium, lead surface, lead cartridge, lead carriage, or lead block. This is a lead block within which a radioactive element, say radium, is placed. Now, since it is a radioactive element, it will emerge particles. It will emerge energetical particles. Such energetical particles are called as the alpha particles. Such energetical particles are called as the alpha particles. When such alpha particles are made, so they move in a beam like structure. So in order to get a serpent beam, he placed two slits. He placed two slits so that the other rays coming get obstructed by this slit surface, by the solid opaque surface of this slit, and light could penetrate it. Now, in the path he placed a gold foil. He placed a gold foil. This is the slit. This is the gold foil. Now, Au is the elemental symbol for gold, and a screen was placed. Screen in the form of zinc sulfide. Was placed. Now, this zinc sulfide surface would have the property for scintillations. What were the observations? So at certain point, so this was the experimental experimental setup of Rutherford's alpha particle scattering experiment. Now this states a radioactive element has been placed inside a lead block so that the decay could be observed through a particular path. Now the radioactive element has been taken was radium, so it started decaying. Once it starts decaying, it leads to the emergence of alpha particles. When a large beam of alpha particles move on, so we cannot get a perfect scintillations. So he placed slits in the path of the light and then allowed a gold foil to be placed in the path of the slit and in the path of the light ray obstructed by the slit. So when he placed a gold foil over here, certain observations were taken into considerations. Certain observations. Now what were the observations? First observations. It was observed that 99.9% लाइफ बॉय कीटाणु जो मारते हैं 99.9% of the alpha particles 99.9% of the alpha particles moved without getting deviated almost every particle every alpha particle passed without getting any deviations. Few of them get deviated through smaller angles. And the last observation was that 1 in 8, if we take lakhs 10,000s as the core number, if we have sent, suppose we have sent 10,000 rays particles into the gold foil surface, and it is taken that 1 in 10,000s, or in some book it is stated as 18,000, 1 in 10,000 or 18,000s of them get deflected, or we can say it bounced back by 180-degree angle. It is some kind of particles are existing which get reflected by the path, or they retraced the path in which they moved on. So observations, I just want you to get recap such observations. It was that 99% of the alpha particles were observed to be to move on without getting any kind of deviations. Now when we think that there is no kind of deviation, then there must be nothing to obstruct the path of the ray of light, or the alpha particles ray. Second point says that few of them deviated through smaller angles, means it later on gave us a statement that something must be present for which these few number of particles get deviated. Now the third was that 1 in 10,000, so comparison must be around 1 in 10,000 get bounced back, deflected or get bounced back, or they retraced their path by an angle of 180-degree. So zinc sulfate was the screen over which scintillation have to be observed. Now what was the conclusion obtained from such kind of things? The conclusions: it gave a complete idea, since 99% of the alpha particles goes on undeviated. 99.9% of the particles goes on undeviated. This gives us the idea that atom have something completely a free space. Atom having completely a free space. Atom has a free space, a large free space. Second point. His second point says few of them get deviated through smaller angles. This means alpha particle, as I discussed, alpha particles are positively charged particles. So few of them get deviated. This means that something of positive value still exists within the atom. Presence of a positive charge body. Positive charge body. Positive charge body. The third point is the most important, because 1 in 10,000 get deflected or bounced back by 180 degree. So if 1 in 10,000 occurring, then it is absolutely clear that there exists a positive charge, no doubt, but the size of the positively charged body is extremely small as compared to the atom. The size of the fundamental particle, size of the positive charged sphere body, size of the positively charged body is too small, and hence the alpha ray particles get deviated only when they come close to this positive charge body. Now the conclusion, once again let us discuss. Since 99.9% of the alpha particles moved undeviated, this makes us conclusion that the atom is having a large free space. Second point said that few of them get deviated through smaller angles. Why they get deviated? Now we have taken consideration that alpha particles are positively charged particles. Now we know that two equal charged particles repulse each other, while two unequal charged particles attract each other. So the presence of the movement of positively charged particle, alpha particles, is somehow deviated, means there must be a presence of positively charged body. Now third point states that 1 in 10,000 of these get reflected or bounced back by 180 degree, means the size of the part, it is no doubt that positively charged body is there, but the size of the positively charged body is too small as compared to that of the atom. This made into conclusion the term, this third statement gives us a conclusion or a new idea about the term called nucleus. So Rutherford discovered nucleus through alpha particle experiment. Now alpha particle experiment gives us the term nucleus. Nucleus is the positively charged sphere around which the electrons are present. It gives us the idea of Thomson, who stated that a positively atom is nothing but a positively charged sphere. Here comes the idea that a small positive charge sphere is there around which electrons are appears to embedded. So this was all about Rutherford atomic model. Then we will come across Bohr atomic model. Thank you.